Welcome back. I am Rakesh Naik. Today we are going to learn about NP-completeness of STAT problem. Before we start, a small request. If you are a new visitor to this channel, kindly press the subscribe button and also press the bell icon so that you will get all the notifications. So, let us start. Basically, Boolean satisfiability problem are abbreviated as SAT problem. SAT, the first three letters of satisfiability. This problem determines if there exists a set of Boolean variables which satisfy the Boolean formula. And we try to determine the value of Boolean values in the form of true, false or 0, 1 that satisfy the Boolean formula. When we say satisfy the Boolean formula, we mean the evaluation of the formula to be true or 1. So basically when you are having a Boolean formula, we have two things. One is a variable and another is operation. A variable will be having a truth value, either true or false. It can be written in the form of 0 or 1 also. And operation can be and, or, not, conditional, biconditional, and all these operations that generally we use in a Boolean function. Here we are going to give a Boolean formula as an input, and the output will say for which combination of the variable the Boolean formula becomes true. Let us say here a formula is given, that is negation of P and Q. For which combination of P and Q, negation of P and Q becomes true. So the combinations are these three sets. For these three sets of values, negation of P and Q becomes true. The Boolean formula negation of P and Q is satisfiable for P equal to false, Q equal to false, P equal to false, Q equal to true, and P equal to true, Q equal to false. Similarly, let us check one more formula, P and negation of P. We are saying that it is not satisfiable because for none of the values of P and Q becomes true, because it is a fallacy. For P and negation of P, for any combination, it is not giving me the output as true. Now, before starting the satisfiability problem, let us try to recall what is reduction. Let us say a problem is given, that is A, and we are reducing it to some other problem, that is B. And the reduction is supposed to be done in polynomial time. Then we can say if A and B are two polynomials, then the problem A reduces to problem B if and only if there is a way to solve A by deterministic algorithm that solve problem B in polynomial time. It means A problem, how much time it will take, we don't know. But we know that B can be solved in polynomial time. If problem A we can reduce to problem B in polynomial time and problem B is solved in polynomial time, then I can say problem A also can be solved in polynomial time. So this reducibility, we use this symbol. If A is reducible to B, we use this symbol to denote reducibility. Now let us see some properties of reduction. If A is reducible to B and B is in P, then A is also in P. If A is not in P, implies that B is also not in P. Now let us check about reduction of NP-complete. Now if A and B are two languages or two problems, let us say, if A is reducible to B in polynomial time, B is NP hard. At the same time, B is in NP also. Then we'll say problem B is NP complete. Now we'll see the steps that is required to solve a NP complete problem. The first step is prove that B is an NP. The second step is select an NP complete language A. Step 3, construct a function f that maps member of A to the members of B. It means here we mean the input members. In step 4, we have to show that if x is in A, if and only if f of x is in B. It means if f of x is in B, then x is in A, and if x is in A, then f of x is in B. And lastly, we have to show f can be computed in polynomial time. If these 5 steps satisfies, then we can prove any problem to be NP complete. So what we are going to do, if input for A is known to me, then I'll transform this to the input of B. This transformation is supposed to be in polynomial time. Now I know the input of B and I know how to solve B. Then I'll solve B in polynomial time. I'll get the output of B. Then what I'll do, I'll reduce the output of B to output of A. This reduction also supposed to take polynomial time. So now let us say what is a NP completeness of SAT problem. Now we know that SAT is NP. Why is SAT is NP? Satisfiability problem. It means if a formula is given, for which combination of the inputs the output become 1. If there are 4 variables in a function and we want to generate the truth table of it, then 2 to the power 4, 16 rows will be having. So as and when the number of variable increasing, the complexity of the problem is also increased. To generate the truth table, it may take a long time. But if the truth value is given to me, to verify it, it will take very less time or it will take polynomial time. That's why I can say SAT problem is an NP. The circuit set or C set reduces to SAT problem. So any circuit satisfiability problem is given, then I can bring it to only satisfiability problem. And the reduction of the function, how can I bring? Let us see. If for each wire that is coming out of a particular gate, let me name it as X out. Then I'll introduce the clause for each gate of K input if and only if X1 input and X2 input and X3 input, for all the inputs it is giving me 1 because AND operation is there. Take AND on all these clauses and on all the X outs. For all these variables, I'll again take a AND gate of their outputs. Now we have to show that if circuit set is NP complete, then SAT problem is also NP complete. So a circuit C is satisfiable if and only if the formula f of C is satisfiable. This is what we know. Then if C is satisfiable, then there exists an assignment to its input wires that results in the output being 1. So based on the input wires, when the value of this circuit becomes 1, that we can find it out. Therefore, there exists an assignment to all the intermediate input-output wires, resulting in satisfying assignment to the formula f of C. If f of C is satisfiable, then satisfying the assignment to the circuit set by restricting it to the variable of the input wires. Now the reduction of the function can be computed in polynomial time, and this can be done by performing the breadth-first search on the graph representation of the circuit, generating a clause for each gate. Hence we can say the SAT problem is NP complete. Thank you for watching this video till the end. Keep watching, keep learning, and please subscribe this channel and tell to your friends. Do post a comment for this. Thank you.